Cloud computing versus edge computing versus fog computing. Fog, edge, and cloud computing have all been frequently used to speed up and improve data processing, as well as to bring intelligence closer to IoT devices that produce data and act on it. In this video, we'll study the advantages of each strategy while comparing these three types of data technologies side by side, learning the differences between cloud, fog, and edge computing. Cloud computing. Currently, the industry standard for IoT data storage is cloud computing. It is a type of computing in which information is kept on numerous servers and is accessible online from any device. Users save information online on third-party servers located in far-off data centers rather than on local servers or other hardware. An account linked to the cloud service must be entered to access data. End-to-end encryption is used so that nobody can access the user's data assets, not even service providers. This entails securely managing and storing a sizable amount of data produced by the Internet of Things environment, as well as having instant access to it from a variety of devices whenever and wherever you need it. Fog computing. What is it? Between edge devices and a traditional centralized data storage system, fog computing functions as a middle layer. The cloud is expanded by fog, which also moves computing and data storage closer to the edge. The key distinction between fog and cloud computing is that fog has several nodes and develops a local network, making it a decentralized ecosystem. The node chooses whether to analyze data locally or to send it to the cloud after it reaches the fog layer. Therefore, since some of the data is also saved locally, it can be accessed offline. Fog computing and cloud computing, in which all intelligence and processing are conducted and stored on distant servers, differ significantly in this regard. How is data processed by fog computing? Sensitive data is transmitted to the cloud's primary data centers, where it's stored and processed. Urgent requests are routed directly to the fog and processed locally in the network. When preserving bandwidth is a top priority, local storage is used. In situations where it's not, the majority of data is stored in the cloud. When the internet connection isn't always reliable, fog computing is helpful. For instance, on connected trains, fog can access locally stored information in location where the internet connection can't be maintained. Additionally, it enables the implementation of data processing at the local network level, which is advantageous for time-sensitive activities and real-time data analytics. When comparing cloud computing with fog computing, this is what makes this strategy more effective and quick. Edge computing. What is it? Edge computing keeps information on the local components of the network, such as edge devices and gateways, processing data away from centralized storage. It enables quick response and offers exceptional speed because the data is processed on-site rather than being transferred to the cloud. The most secure type of decentralized storage is edge computing. When using edge computing as opposed to the cloud, which uses dozens of servers, data is distributed over hundreds or even thousands of local nodes. In the edge network, each device can function independently as a server and process data. Hackers would need to have synchronized access to thousands of scattered devices to gain access, which is virtually impossible. Fog acts as a network that links to the cloud, whereas edge devices can be loosely connected and act on their own. This is another difference between fog and edge computing. Difference between cloud, fog, and edge computing. The location, timing, and method of processing and storing data from devices connected are the primary distinctions between cloud, fog, and edge computing. More than any other sort of storage, the cloud is a centralized storage system that is located far from the endpoints. This explains the majority of the latency, bandwidth expense, and network requirements. The cloud, on the other hand, is a powerful, universal solution that can successfully scale by utilizing more processing power and server space and managing massive amounts of data. Big data analytics, long-term data storage, and historical data analysis all benefit greatly from it. As a layer in between clouds and edges, fog offers the advantages of both. It utilizes the cloud and communicates directly with it to distribute data that doesn't require immediate processing. Fog is also positioned nearer the edge at the same moment. It uses local processing and storage resources as needed for real-time analytics and quick event response. Fog is decentralized, meaning it has numerous nodes just like an edge. Fog, in contrast to the edge, has a network architecture. Fog nodes are interconnected and can transfer computing and storage to more effectively complete certain tasks. The edge provides the lowest latency and fastest reaction to data because it is the closest to end devices. This method enables processing to be done and a small amount of data to be stored directly on devices, applications, and edge gateways. The structure is typically loosely coupled, allowing edge nodes to handle data on their own. This sets edge fog apart from the network-based fog. Advantages of cloud computing, fog computing, and edge computing. Although less well-known than the cloud, edge and fog computing have a lot to offer businesses in general and IoT firms in particular. These networks address a variety of problems that IoT cloud computing providers are unable to address and customize decentralized data storage to meet specific requirements. Let's look at the advantages of edge, fog, and cloud computing separately. Benefits of fog computing. Minimal latency. With minimal to no delay, the fog network can process massive amounts of data. Large amounts of data are kept locally, which speeds up computing. Better data management. Third-party servers are completely cut off from local networks in cloud computing, giving users little to no control over their data. Users can manage a lot of data locally in fog computing and rely on their security mechanisms. A flexible system of storage. Fog computing doesn't need constant access to the internet. Data can be locally stored or accessed by requesting it from local disks. This type of storage combines online and offline access. Integrating storage from centralized and decentralized sources. A smooth shift to totally decentralized data storage is made possible by fog computing, which creates a link between local drives and outside cloud services. Many businesses use edge computing as a stepping stone toward decentralization, while others use fog computing as their primary system for data storage because of its fast speed and greater availability. Advantages of edge computing. There are no processing delays. The information remains at the edges of the IoT network and is immediately actionable. Analyzing data in real time works well when data needs to be processed quickly. Minimal network activity. Local processing is done on site before the data is transferred to the main store. Lower operating expenses. Data management requires less time and processing resources because it goes in one direction rather than back and forth between the center and local disks. IoT edge computing is the best option for processing quick, tiny operations at millisecond rates. Local processing of minor activities is quicker and more cost-effective when several small processes are occurring simultaneously. Cloud computing advantages. Abundant resources. Cloud computing is always the most resourceful method for maintaining a large volume of data when compared to edge computing, fog computing, and cloud computing. Modern cloud technology offers end-to-end services to handle IoT data, including security, cutting-edge data analytics, visualization services, and the like, in addition to excellent computation and storage capacity. This also explains why cloud business intelligence is so popular for building high-load applications and websites. Scalability. In comparison to edge and fog, the cloud enables faster, easier, and more cost-effective scaling. Simple to maintain. Platforms in the cloud offer resources and services for quick, affordable maintenance. The role of edge, fog, and cloud computing in the future of IoT. Because these technologies complement one another, cloud, edge, and fog computing are frequently mentioned in connection with IoT. To store and analyze IoT device data and metrics, enable automation, and the like, various data management services are used. Let's look at how cloud computing and IoT assist businesses and end consumers, and why combining them makes sense. Increased scalability. For IoT systems to operate well, a lot of data must be produced, exchanged, and stored. AWS, Microsoft Azure, Google Cloud IoT Service, and IBM IoT Platform are just a few examples of cloud platforms that give users access to robust cloud services that can manage the steadily increasing volume of IoT data. Improved safety. IoT services should rely on secure data storage that can resist attempts by hackers to access the system and endanger it. One method for protecting sensitive materials is decentralized storage. In contrast, centralized cloud systems offer built-in security to safeguard massive amounts of data. The Internet of Things currently enjoys several advantages thanks to cloud technology, but advancements continue. For many Internet of Things problems, cloud, fog, and edge technologies currently offer unbeatable solutions. Let's look at some potential applications for the Internet of Things and various computer technologies in the future. New alternatives for deployment. The Internet of Things, or IoT industry, is expanding quickly, and every gadget will likely be connected in the future. Massive amounts of data are produced every second by smart buildings, vehicles, machinery, and other items. The need for computing power in devices will only increase, and cloud computing provides decentralized storage options for quicker and less expensive installations. Utilizing IoT cloud platforms allows developers to make use of built-in security, data management services, and third-party computing capacity. Clever analytics. Systems using the Internet of Things generate a lot of data. It can help firms and developers get to know their customers better. Cloud services offer a secure setting in which to handle, store, and analyze this data. Numerous services currently have AI features, such as machine learning algorithms that model data insights and enable automation. Improved security. Millions of connected devices and the users using them could be compromised by a security breach in IoT networks, which could also affect the entire enterprises and industries. Cloud storage is more difficult to attack due to its distance from the target and security measures. Devices will eventually be able to use previously gathered data to identify vulnerabilities even before they manifest. Device-to-device communication. By facilitating rapid data transfers between data centers and nearby nodes, the cloud enhances communication between hardware and software. For offline communication and micro-operations carried out at the edge, where this data is produced, fog and edge computing can be effective for lowering operating costs and boosting performance. In the end, it's up to the company to decide which computing is best for them. This ends the video for today. Tell us which computing you prefer. Like, share, and subscribe to the channel to find out more.